Hello everyone, in this video we will discuss about induction motor drives. So already we have seen DC motor drives. So DC motor drives are having some drawbacks. So what are the drawbacks are there in DC motor drives? What are the drawbacks are not there in induction motor drives? We will see first, and we will see the analysis of induction motor drives. The main drawback of the DC motor drive is presence of variable speed. Induction motor requires frequent maintenance. So here the DC motors are requires frequent maintenance and also unsuitable for explosive and dirty environment. So that is the main drawback of the DC motor drives. So other hand, so if you take induction motor drives, so those induction motor drives are particularly squirrel gauge induction motors are, so that is strong, rigid, cheaper, lighter and smaller, more efficient, require less maintenance and can operate in dirty and explosive environment. So these are the advantages are not there in DC motor drives. That's what induction motor drives are more popular than the DC motor drives. And also DC motor drives are having commutator and construction wise complex, but if you take induction motor drives, the construction is very simple, there is no commutator. That's what in induction motor drives are less maintenance than the DC motor drives. So maximum applications we will prefer induction motor drives instead of DC motor drives. So next we will see the applications of induction motor drives. So induction motor drives are used in fans, blowers, mill runout tables and cranes, conveyors, tractions, etc. And also we can use in this type of induction motor drives in lifts. So lifts will use this type of induction motor drives. So next coming, this is the introduction of the induction motor drives. Next coming to the content of induction motor drives. The first content is analysis performance of three-phase induction motor. That is a very important. Generally, this question, this topic will ask in VTU examinations. Explain the analysis performance of three-phase induction motor drives. Next, so here coming to the equivalent circuit, so always we will measure in terms of per phase. The per phase equivalent circuit of three-phase induction motor shown in the below figure. So R dash and XR dash are the stator referred values of rotor resistances. RR and rotor reactance is XR. So here next one, slip. Generally we have seen in earlier classes, slip is equal to Ns minus N divided by Ns. Ns is synchronous speed, N is motor speed divided by synchronous speed Ns, right? So here in this in drives, what we will take is angular velocity, that is omega we will consider. So here omega ms motor synchronous speed, omega m that is motor speed. So the slip is equal to omega ms minus omega m by omega ms, where omega m is equal to 4 f by p radians per second. So there ns is equal to 120 f by p will take here. So what we will take is omega ms, angular velocity of motor in terms of synchronous speed is equal to 4 pi f divided by p radians per second. That is the one thing. So next one here, where omega m and omega ms are the rotor and synchronous speeds. So where f and p are supply frequency and number of poles. So since stator impedance drop is generally negligible compared to the terminal voltage V, the equivalent circuit can be simplified as shown in the figure 2. The first one is without simplification of equivalent circuit of induction motor drive. It is similar to the transformer equivalent circuit. So if you observe a transformer equivalent circuit and induction motor equivalent circuit, looks similar, almost 80% is similar. So here RS and XS, so stator resistance and stator reactance. Next one XR dash RR dash by S, that is stator referred rotor reactance and rotor resistances, right. XM is the that is magnetic reactance of the induction motor here. Then E represents the induced EMF. Even once motor starts rotates, EMF will induce, that is called as a back EMF, that is E. E is here. The figure 2 shows the equivalent circuit of the induction motor, that is a simplified equivalent circuit of the induction motor. So from equation 1 you can write, from this equation 1 what we can write, omega m is equal to omega ms into 1 minus s, that is equation number 3. So from figure 3 what we can write, R dash rotor current is equal to V by RS plus RR dash by S plus imaginary term J into XS plus XR dash. Next one, power transferred to the rotor or air gap power, that is PG is equal to 3 I R dash square into RR dash by S. Next one, copper losses, PCU is equal to 3 into RR dash by RR. So compare these two equations. In denominator S will be there in power transferred to the rotor, in copper loss S will not be there. Next one, mechanical power. So that is developed in induction motor, that is electrical power converted into mechanical power, that is mechanical power developed by the induction motor. PM is equal to power transferred to the rotor PG minus copper losses. If you simplify you will get that expression, equation 7. Next one, torque developed by motor. Torque is equal to the ratio of power developed in the motor to motor speed, Pm by omega m. From equation 3 and 7, so we can get torque developed by motor T is equal to 3 by omega ms into IR dash square RR dash by S, that is the one equation. Next one, so here from equation 4 you substitute here RR dash in this here. So finally you will get the this expression. So T is equal to 3 divided by omega S into V square RR dash by S whole divided by RS plus RR dash by S whole square plus XS plus XR dash whole square, that is the one expression. So now comparing equation 5 and 9, equation 5 and 9, so what we can suggest here, T is equal to PG divided by omega S. So equation 5 is this one and equation 9 is this one. So you can say that T is equal to PG divided by omega S. The motor output torque of at this shaft is obtained friction, windage and core losses from the developed torque. Next one, the torque developed is a function of slip only, equation 10, that is equation 10 shows the slip. So next one, differentiating with respect to T in equation 10 and equating to 0, so you will get the maximum torque. So here maximum torque Tm is equal to 3 divided by 2 omega ms into V square by Rs plus or minus root of R square plus Xs plus XR dash whole square. So you will get equation 12 into 10, right. The maximum torque is also known as braking torque. So this is the one thing. Sm is directly proportional to the rotor resistance here. Sm equation 12 you can take Sm is directly proportional to the rotor resistance. So next one here, both rotor current and torque are 0 at synchronous speed. So if from this figure you can say both rotor torque and synchronous speed is 0 at so here torque is synchronous speed 0 when both rotor current and torque are 0 at synchronous speed, right? So next one, with decreasing in speed, both increases while torque reduces after reaching the breakdown value. The rotor current continues to increase, reaches a maximum value at 0 speed. So here from this figure you can see the how this here the torque will reaches on maximum value and it will decrease to 0, and also rotor current also will decrease, right? When rotor current is decreases when speed is decreases. So the drop in speed from no load to full load depends on the rotor resistance. So coming to the equation 10 and 13, substituting in equation 12, so finally you will get T by T max. The ratio of torque to maximum torque is equal to this expression. We will get 2 into 1 plus Rs by Rr dash Sm divided by Sm S by Sm plus Sm by S plus 2 into Rs by Rr dash in Sm. So if it is negligible, so finally what you will get T by Tm is equal to 2 by S by Sm plus Sm by S. So from this equation, if it is Rs by Rr dash, if it is negligible, so finally you will get T by T max is equal to 2 by S by Sm plus Sm by S. So this is about analysis performance of the induction motor, 3-phase induction motor. So next video, so we will see about operation with unbalanced source voltages and single phasing. Suppose if you supply unbalanced voltages to the induction motor, what will happen? So those things we will see in next video. So, I request all students to watch the videos and comment your opinion. So by that we will also improve our videos, and we will also come to know so what are the requirement of students. So we will see and we will improve the next videos. So thank you, and also submit the assignment what we have uploaded in Google Classroom, so within the date. So thank you once again.